up in Manchester and as a boy was deeply inspired by the American astronomer Carl Sagan. But his interest in the stars had to wait. Brian learned the keyboards and became a pop star. But the call of science eventually won over musical celebrity. He found his new calling in particle physics and the origins of life and the universe.
The stars are out.
He's the co-presenter of the ABC series Stargazing Live, which clinched a world record for the number of people looking at the night sky at the same time. Brian Cox, welcome to 1+1. It's good to see you.
Pleasure to be here.
You are a professor of particle physics at the University of Manchester. You're also a co-presenter of the ABC series Stargazing. I woke up to news today about a massive black hole that was so powerful, I think it could suck up the sun in 2 days. For a scientist, does that kind of information make you optimistic or pessimistic?
Hugely optimistic. Black holes, they're fascinating things. Perhaps it's one of the first things we learn about and become fascinated with as a child, the black hole.
It's a great word, isn't it?
It is. But actually, they represent the edge of our knowledge. If you ask what happens at the centre of a black hole, this so-called singularity, where it's kind of infinitely dense, or is it infinitely small? What happens there? The answer is we don't know. We don't have the physical theories to tell us about what happens at the centre of black holes. And so that's a signal that our knowledge is breaking down. And that's why ultimately we want to study them, because they're a gateway to new knowledge. And we're in an era now where for the first time we've been able to observe them. So we can make these discoveries, as you said, these supermassive black holes at the centre of galaxies, millions of times more massive than our sun, but also seen them collide. We've recently, the Nobel Prize was awarded for the observation of colliding black holes, which nobody would have imagined we could observe even 10 or 20 years ago. And the reason it's interesting is not just to see these things bang together, but it allows us to test our most fundamental theories, or the most advanced theories of what is happening, how the laws of nature work in those extreme conditions.
But as mere humans, do we take this as a kind of powerlessness on our part?
If you're asking about the size and scale and violence of the universe, then yes, actually, I think that it's a great challenge to us. Cosmology and astronomy, Carl Sagan, one of my great heroes, said it's a humbling and character-building experience. Now, being humbled and having your character built is something that we should all aspire to.
The lives and deaths of the stars seem impossibly remote from human experience, and yet we're related in the most intimate way to their life cycles.
And the questions are raised immediately. We are one planet around one star amongst 200 billion stars in the Milky Way galaxy, which is itself one of 2 trillion galaxies in the observable universe, and we think the universe extends way beyond that and could be infinite in extent. What does that mean for our existence? What does it mean to have a small and fragile and finite existence in this vast and sometimes violent universe? Well, that's the question that I think we've been asking ourselves since we began asking ourselves questions. It's often a cliche, but it is true to say that throughout history we have wrestled with, perhaps the great art, the great music, the great achievements of our civilization have been based on wrestling with that question, which is what is our place as finite beings in an infinite universe. And so that's why I think cosmology and astronomy can be great cultural forces, because they focus those kind of questions, I think, and bring them into vivid focus.
When did you start to ask those sorts of questions as a kid?
As far back as I can remember, honestly, I've been interested in astronomy. For some reason, I caught this bug of looking at the stars. And also, the first step to being a scientist is to ask questions about them. Obviously, what are they? What are those points of light?
Because your parents weren't scientists, were they?
No, they worked in banks in Oldham, near Manchester, which is a small sort of provincial town in the north of England. And so, not really. And my grandparents worked in cotton mills, which is what everybody did in those days in Saddleworth and Oldham. So no real scientific background.
Did you know your grandparents? Was life hard for them?
Very well, and not actually, but by the time I got to know them, they'd done okay. And actually, my life is a classic 20th century English or British story, actually, which is grandparents. My grandfather on my dad's side was born in 1900, so he lived an incredible life. He lived until the early 80s, actually. And so he'd seen, he just missed the First World War because he was just too young. He was too old to fight in the Second World War. But he'd seen the 20th century.
Yeah.
And what he wanted for my dad was for him to do better than he had done. So my dad did A-levels at school, which is he was educated at the age of 18, which my grandfather, I think, had left school at 14. But he didn't go to university. So my mum and dad wanted was for me and my sister to go to university. And we did. And so we were the first people in our family ever to go to university. It's a classic 20th century story. And I worry, actually, I don't know what it's like in Australia, but in the UK it's getting more difficult again for that progression to happen.
Why do you say that?
I think there's a concern that what we call social mobility, in that sort of jargon, is getting harder for people from backgrounds where particularly your parents didn't go to university. It's getting harder for those people to go to university and have that chance that I had. I find that children today, when I interact with schools, have a thirst for knowledge, and actually, certainly in the UK, they're almost more aware of the fact that they're going to have to work hard. Too aware, in fact, I think. I mean, I tend to say to my students, you're here to learn about nature. Like, you're not here to put yourself in a position where you can get a good job. You're not on a production line. It's a fodder for the knowledge economy. That's not what you are. If you learn about physics because you're here, you learn about astronomy or whatever it is, and you enjoy it and you do well, you'll have no problem getting a good job and having a great time. But you're here to acquire knowledge for the sake of it. And I think the battle that I've seen recently is, I think, because of the pressures on young people, which must be the same in Australia as they are in the UK. You've got a housing market, it's very expensive. And you seem to be growing up too early. I don't want you to grow up until you've left university. I want you to be, acquire knowledge and be a rebel, essentially. Don't care about all that sensible stuff. Just enjoy learning.
So let's go back to your childhood. I think you taught yourself how to play keyboards at one stage because you thought, I know, I'm going to be a pop star.
Yeah.
So what happened to that kind of thirst for learning around that stage?
Well, it was... so I'd always, as I mentioned earlier, I'd been interested in astronomy from a young age. So that I somehow translated that into physics, which is a big step, actually, to go, you have to do physics at school. I have to do some maths because I want to do this. But then when I was 16 or 17, you're right, I discovered pop music. I was kind of always interested in music, actually, and listening to it. And then I thought, OK, maybe I could be in a band. And so I taught myself how to play. And fortunately, I did end up in a band, and we got a record deal. And so I kind of drifted away for a bit. But at the age of 22 or 23, we'd made a couple of albums, and I made the decision, actually, to go back to university to do that thing, to be an astronomer, as I wanted to be then.
That must have been a tricky decision, given that you actually had achieved quite a bit of success for a young pop star.
Yeah.
Was that not kind of appealing to stay with that?
I like learning curves, and I've really realised this about myself. Sort of later in life, as you analyse yourself more, that's what it was. But I was dissatisfied with the repetitive nature of going out, and recording an album and doing some live shows and doing that. And it just seemed, it was very exciting for 3 or 4 years, but then just became not satisfying.
At one stage, I think you worked at the Large Hadron Collider. Yeah. Does it ever amaze you that such a huge device actually got built?
CERN is a fascinating place. It's been around since the 1950s, and it was built after the Second World War deliberately to bring Europe together, to focus Europe's endeavours, particularly in the field of particle and nuclear physics. And but as a way of generating knowledge for the sake of knowledge. It's a very utopian idea that countries, 20 countries, 30 countries, there's something like 85 countries now,
can
collaborate together just to generate knowledge for the sake of knowing. And that's built into its constitution. So it's a special place, which, as you said, allows us to build these machines. It's 27 kilometres in circumference. I mean, in many ways, the most complex machine we've ever built in human history. But because so many countries collaborate, it is not particularly expensive. It's often thought of as being this huge, how can you get all the money to do this just to generate knowledge? But actually its budget is about the same as the University of Manchester's budget. So it's like one extra university for the world that focuses on the edge of this particular sort of knowledge.
So it's really the cooperation that keeps it together more than the money.
It's the cooperation, yes. And it's also, and the cooperation is part of the reason for doing it. The other example of that is the International Space Station, actually, which if you speak to the astronauts, they'll say one of the great achievements is we work side by side, particularly with Russia, but also many other countries as well, in peace to generate knowledge. And that you have to ask, what is the point of the human race, right? Really, what's the point? And part of the point is to find out how nature works and to generate new knowledge. That's been immensely valuable for us in the past. But it's what it means. It is part of what it means to be human.
You got into TV, I think, after you'd done some interviews with the BBC.
Yeah.
And since doing TV shows, you've done huge live shows. I wonder, where does your next learning curve take you?
That's a good question, and the answer is I don't know. It is true, though, that I find myself thinking, well, I've kind of done that, and television is enjoyable but also frustrating, as you probably know, and live shows are they're great fun, and this tour I'm doing next year is the biggest thing I've tried to do. And what's wonderful about that, it is a learning curve, because when you do a very big tour, it means you have a lot of resources to put into the show. So I'm working with a big graphics company who did graphics for the movie Interstellar, for example, on recreating black holes on stage on these huge screens and simulating how they would look as you fall into them and things. So that's exciting for me. And also good physics for me, because I'm learning a lot about general relativity and black holes I didn't know. But ultimately, you're right that I don't see myself doing that forever, because I've done it for 10 years and I have a bit of a track record, actually. The only thing I've done for my whole life has been physics, actually. And actually, I got into Sydney on Monday evening, and yesterday I was supposed to be relaxing. I spent all of it, reading a textbook which had just been published by Kip Thorne, who's also coming to Australia, actually, one of the greatest living physicists. And he's written this amazing textbook which he's been writing since 1980, I think, and it got published last year. And I was doing some of the exercises in the textbook because I found it so exciting, because his way of looking at physics is different to anything I've seen.
You get asked a lot about faith and religion, and I think you've stated that you have no personal faith. But I wonder whether in your kind of non-physicist life you've ever had an experience that's made you truly wonder about the nature of belief and who made the world and what made the world and that sort of thing.
No, not in that context. I have experiences that make me wonder about nature, and I want to find out more about it. But no, I've not and never have reached for any kind of supernatural explanation. I think being a scientist is one of the key traits you have to have is to be comfortable with not knowing. Because if you think about what a research scientist's job is, it is to go to the edge of your knowledge and peer out into the unknown and try and find out some more stuff. So if you're not comfortable with being on the edge of knowledge and not knowing things, then you can't be a research scientist, really, in my view, anyway. So you have to enjoy the unknown. And so I don't know. We don't know. Nobody knows how the universe began. We have a reasonably good idea when it began, but we don't have the tools at the moment to understand precisely how it began. If indeed it did, I mean, there are some theories now that say that everything has existed forever again. We just don't know, basically. By the way, I'm careful, though, because I think that religion is part of the obviously part of our history, and it's part of that. It's a reaction to nature, and it is I have a friend who was the dean of Guildford Cathedral for many years, actually, and he said that the point of his cathedral was to make people go in and think of something else. So they're doing their shopping on a Saturday afternoon, and then they go into this grand building, which is a haven in a sense, but also overwhelming in scale. And it's to try and make you think about something else. And that was the key point for him. And afterwards, the next step is, what are you thinking of? And that's, we may agree or disagree. But that idea that these are responses to as we talked about at the start of the interview, of I use the word terror, actually. I think there's a great quote by John Updike that says that cosmology is what we now have instead of theology. The terrors are less, but the comforts are nil, which I think is a great quote. And there is an element of that. So I'm not a critic of religion or people who have faith at all. And that's why I tend to say that careful wording, in my view, which I have no personal faith. I'm not a figure who wants to sit there and say, "Oh, religion is nonsense."
Yeah, you're not a Richard Dawkins or something like that.
These are reactions to the human condition. Same for art and music and literature and science and religion. These are all reactions to the human condition. What we really want to know is what are we to make of this life that we have?
You've done shows and done a lot of reading on the issue of space travel. I really like this quote. You said, one of the problems we have is that we don't have a point today. Yeah. Our existence is almost pointless. We just consume stuff. We don't have a frontier at the moment. Yeah. But sometimes it seems that the very sort of disparate attempts to explore what's out there, they're just such tiny needlepoint stabs in the dark, aren't they?
Yeah, and always will be. Even on the scale of our galaxy, our local little island of stars, will we ever explore it? It's 100,000 light years across, our island of stars. But that's not the point. Science is about taking small steps. And who would have thought, when the first steps to modern science, people like Newton, or perhaps Copernicus, Galileo, only 500 years ago at most, were taking those first small steps. They couldn't have imagined we'd be observing colliding black holes. They didn't even know such things existed. So we've been quite fast in this process. Space exploration, though, it's important, as you said, the idea that we have an intellectual and physical frontier is very important, because a civilization, I think, needs to expand both physically and in its knowledge in order to survive. I don't think stasis is an option for human civilizations. The history of civilizations tells you that. And now we're one civilization, and there is no frontier on the planet. Really, you could argue the deep oceans, but there's no real physical frontier. So what are we going to do? Where do we go? Where do we access new resources? Where do the adventurous amongst us go? What do they do? That's necessary to have a place for your adventurous citizens to travel to. Well, the next frontier is the asteroids and Mars and the moon and beyond.
When you hear about news such as water plumes on the moon of Jupiter, on Europa, I mean, that just what does it do to you when you hear that?
That world, I mean, that's a world with an ocean beneath the surface with more water than our oceans on Earth. It's got volcanic activity on the floors of those oceans and the plumes. So this is water rising up from a frozen surface, telling you there's activity there. Well, those are the places where we strongly suspect life on Earth began 4 billion years ago. That interaction between geology and water and the transition from geochemistry to biochemistry, which happened here, that those conditions look like they're present on that moon. So suddenly you go, well, we've got to go to that moon. We've got to fly a spacecraft through those plumes and see what's in there. Is there evidence of biology in those plumes? We don't know. But there would be an answer to a question, are we alone in the universe? We'd say, no, we're not alone. That discovery is there waiting to be made. And it perhaps inside our solar system.
We're not alone, but I don't think you believe that there is intelligent life out there?
Oh, I'm sure, and I'm sure there is in the universe because it's big. I mean, it's possibly infinite in size, so there will be. But more relevant, the only relevant question for us really is there intelligent life so close enough that we'll meet it? You can make the argument that in a galaxy of the size of the Milky Way, there could be very few, or even on the average one, civilization at any one time. And actually, it tends to be biologists that make that argument. Astronomers tend to say there's loads of stars. We've seen planets around virtually all of them. There's an estimate that there are 20 billion Earth-like planets in the Milky Way galaxy alone. 20 billion. So you think, well, surely. But you speak to a biologist and they'll say, yes, but it took 4 billion years to go from the origin of life on Earth to a civilization, which is a third of the age of the universe. And if that's somehow typical, if that's the kind of speed that biology tends to produce human brain-like structures, then it could be that there are very few places that are stable enough for long enough for that to happen. And so I have a friend at Manchester University, a professor of biology, who says, look at the Milky Way there. It's beautiful in Australia. You're pointing toward the centre of the galaxy. Look at that. All there will be there is slime at best. And that actually goes, it's a profound point. What would it mean for us if there were very few civilizations? Let's say there's one per galaxy and it's us. So in all those stars, every single star that you can see with your eyes, nothing, nobody thinking, maybe microbes, but no objects, collections of atoms like us, that can bring meaning to the universe, because that's what we do. Meaning exists because it means something to us. Meaning is local and temporary, in my view. Let's go back to the religious question. I think meaning is local and temporary. That makes it more valuable and more precious, but it puts the responsibility squarely on our shoulders to make sure that meaning exists for as long as it can in a galaxy. Now, that's not a kind of, it's not a trivial observation. It sounds a bit way in a way, but it's not. It's extremely important.
But it's also a universe away from my world of news, where, you know, you've got an embassy opening in Jerusalem and people dying as a result of the fighting. It's like, you know, perhaps if we all took a much bigger picture, would we behave any differently?
I think so. I think that perspective, that challenge, there is a challenge that astronomy and cosmology delivers that I think nothing else does really. Biology does as well, actually. The fact that we've got 4 billion years from single-celled organisms to the human race is an interesting time span. These all point, science points us in the direction of responsibility and says that, you know, we're the most complex and I would say valuable structures in the universe. We are only, as Richard Feynman, the great physicist, said, atoms that contemplate atoms. But what a thing to be. And I do think, I might be naive, and you cover politics more than I do, but I do think that if more people took that view, that actually we are a valuable and potentially quite unique thing, then the first thing we'd do is say what all astronauts say, which is that, well, we're self-evidently one planet. It is obvious. So I'm not naive enough to think there aren't differences that create tensions on a planet this size. But ultimately, we are one planet. And if we're going to survive into the far future, or even the medium term, we will have to learn to live together, become a spacefaring civilization, and begin to step out to the stars. We have to do it. There's no doubt about it. So the question is, will we do it in time before... there's a great Robert Oppenheimer who ran the Manhattan Project famously. In the mid-1950s, he did some lectures for the BBC called the Reith Lectures. He was surprised that he existed because he felt the power that physicists and engineers had given to politicians could not be controlled in the form of the atom bomb. So he was very surprised. But he wrote a passionate series of lectures saying that science can provide the means to destroy our civilization, but also the way of thinking, which is a humble way of thinking, a way of thinking that says there are not right answers, to be definitively right and to say this is the way to do things. In science, that's not the way it works. And he felt that was the most valuable thing that science could give to politics, was the idea that you can be wrong You can never be absolutely right, but you can be wrong. And also you have to look at things in different ways in order to understand them properly and fully.
It's surprisingly emotional talking about these very big questions of humanity as opposed to, the in and outs of daily news and politics. But I wonder, for you personally, do you have an ambition that you'd sort of like to say when you finish this current learning curve, I'm really glad I did that. That was worth it?
Oh, I mean, almost in terms of the things that I've done and learned.
Yeah.
Almost everything, actually. I'm glad I did almost everything because, as I said, we have we don't have very long on this in our lives. And there's a lot of knowledge to be acquired and there are a lot of things to do. And, we're only going to scratch the surface. So I feel that I've been lucky that I've been able to have several careers. And the one thing that will be constant, though, is science. Because all science is learning.
But you don't sort of think, I've filled out more stadia than anyone else talking about astronomy or anything like that. You don't sort of look at your achievements, I suppose, in that vein.
No, not really. I mean, the only thing I would say is that I was inspired by people like Carl Sagan, actually Stephen Hawking in A Brief History of Time, those books and television programmes like Carl Sagan's Cosmos. And so I do find it satisfying when sort of children will come to me. I've managed to spend long enough in television that 10 or 11, 12 years, where an 18-year-old can come to me and say, I was inspired to go into physics by your programme 10 years ago. It makes you feel very old. What do you mean? And they say I watched it when I was 6, or 8, and now I'm at university. So there is that. If there's anything that I would look back and say I'm proud of that, it would be that I would be proud of inspiring some younger people in particular to go into science.
It's been such a great pleasure speaking with you. Thanks so much for coming on to 1+1.
Thank you very much. Very much enjoyed it.